So I'm going to give a short lecture on how to find the LCM of two numbers. LCM, least common multiple. I don't know if you can see what I just wrote. Let's see. All I could find was green markers. Doesn't look good. I think in the book they call it LCD, for least common denominator. Let me check to see if I have a different color marker. I should have blue. Let's see if blue's better. Yep, it is, I think. LCD. Yeah, so you can't probably see that great. Let me move it a little closer. So, least common denominator, least common multiple is used when we have to add fractions or subtract fractions. So, there are three ways. I'll discuss doing it. So, the first way, let me erase this. First way, the easiest way probably, only really suitable for small numbers. Given two numbers, let's say we want to find the LCM of 8 and 20. You can just list out all the multiples of both of the numbers. So let me list out some of the multiples of 8. I'll do 3 at a time. Makes sense to do 3 at a time. I don't see any common ones yet, so I'll do 3 more up here. Now I would do 3 more, but once I get to the second one, I see that we have a common multiple. And it's the least common multiple. There's nothing less than 40 that's in both rows. So 40 is the LCM of 8 and 20. So that's probably the easiest way to do it. I know this video seems kind of strange because there's a delay in the camera and it's kind of making it hard to do. So that's the least complicated way to do it, but it's only really suitable if the numbers are small. The other way to do it, one of the other ways to do it, is to do the prime factorization of each number. Can you see what I wrote here? It says hi. Do the prime factorization of each number. So I'm going to pick some bigger numbers here, maybe not too big. 18 and 100. I hope you can see that. I'm going to obviously review this video before I post it, and if it doesn't look good, I won't post it, obviously. That means, if you can see this, then I think this looks good, which probably really doesn't, but anyway. Do the prime factorization of each number. Now, if you were in class on Friday the 13th, Friday, March 13th, which a few of you were, very few, we talked about prime factorization because I showed everyone how to find the GCF of two numbers. Well, if you look in the new book, the book that you got electronic access to through Cengage, the new edition of the book doesn't actually talk about GCF. It did in the version, the 6th edition, but it doesn't in the 7th edition, which is weird because GCF is important to simplify fractions. Knowing the GCF of two numbers, if you want to simplify fractions, is pretty important. Not really necessary, but it's pretty important. So I talked about it. So if you're doing the prime factorization, that means you want to break this down into all of the prime numbers that you need to multiply to get 18. So using our divisibility rules, I know that this is an even number, so I know 2 is a multiple. Or 2 is not a multiple, it's a factor. So 2 times 9 is 18. Once I get a prime number, I circle it or put a square around it. 9 I know is divisible by 3 because of divisibility rules. Sort of because of divisibility rules. It's actually just a fact that 9 is 3 times 3. So the prime factorization of 18 is 2 times 3 squared. Okay, for 100, I know 10 goes into this because it ends in 0. So I'll do 10 times 10. Now if you're wondering how I know when a number is prime, I talked about that on Friday too. Friday the 13th of March. I think I'm going to make sorry, I walked out of the screen. I think I'm going to make another video on how to test to see if a number is prime. But for any number that's less than 100, you should just remember if it's prime or not. Can't remember how many numbers less than 100 are prime. It's in between 20 and 40. So there's not that many really. So the prime factorization of 100 looks like this. 2 squared times 5 squared. Now, once you have the prime factorization, to find the least common multiple, you take numbers that are in either one. So we have a 2, 3, and 5. So you take 2. So it doesn't just have to be in one of them. Like, if you notice, 3 is only in this one, 5 is only in this one. Now for greatest common factor, it has to be in both. But for least common multiple, it doesn't matter. You just take any number that you see here. So I see 2s, I see 3s, and I see 5s. And then you take the highest power. So 2 to the first power, or 2 to the second power. The biggest one's 2 to the second power. These are both just, there's only one, there's just 3 squared and 5 squared. So you have 2 squared times 3 squared times 5 squared, which is 900. So 900 is the least common multiple of 18 and 100. So it would be hard to list these out like I did with the last example with, what was the last example? 8 and 20, I think? Yeah, 8 and 20. Listing out the multiples of 8 and 20 to find the LCM, it didn't take that long. Notice that since this is 900, we'd have to do like 18, 36, 54, 72, 90, 108, yeah, it would take a long time. So this is a better method if you have bigger numbers. Just do the prime factorization. Take any number that you see. So I have 2s, I have 3s, and I have 5s. Then you take the highest power. Okay. I'll probably come back and do another example like this, but I want to show you the third method. Third method actually talks about, or needs you to know how to find GCF really. So we could actually do the same numbers. So I could probably leave everything the same. We could do the same numbers here so you see that it works. Then I'll pick bigger numbers. This gives me a chance to show you how to do GCF too. I forgot to bring something to drink, so probably this video won't be that long. Either that or I could run out and get a drink. That's probably not going to happen though. Alright, so I don't know why I erased this. You know, if you've ever been to class, which if you're watching this video, you've probably been to one of my classes because you're in my class. I do a lot of stupid things. Like I erased this. which I didn't want to erase. I'll still need this. But that's why we're going to do another example of different numbers, so I can go through all this again. So, we just found the LCM of these two numbers, and it was 900. Okay, now I'm going to show you how to find the GCF. If you weren't in class on Friday, the 13th of March. GCF of these two numbers, you take any number that's in both. It has to be in both. Well, if you notice that the only number that's in both is 2, then you take the lowest power. So we have either 2 to the first or 2 squared. So 2 to the first is the lowest power. So you just have 2 times nothing, really. So it's just 2. So the GCF of 18 and 100 is 2. So how are you going to use that to find the LCM of these two numbers, which we already know is 900, is there's a simple formula, I guess you'd call it a formula. Now I do want to erase this. Okay, so there's a formula that links GCF to LCM, and that is this. The LCM of two numbers, A and B, I know those aren't numbers, but you know it's math. We talk about, in general, two numbers, A and B. The LCM of two numbers, A and B, is given by A times B over GCF of A and B. I don't really like to write multiplication like that. You can, but I don't like it. I'll just write A times B over GCF of A and B. So in this example, let's see if we can still see this. Yeah. We just figured out that the GCF of these two numbers was 2, and 18 times 100 is going to be 1800 divided by 2. So obviously you get the same answer. If you didn't get the same answer, that wouldn't be a legitimate way to do it. So we're going to find the LCM of two even bigger numbers by using this fact that there's a link between GCF and LCM. And I'm going to show people who missed it how to do that, because it's kind of interesting. And it's not in the book. They don't even really talk about GCF in the new edition. At least I couldn't find it. I didn't really look that hard, but I'm pretty sure they don't talk about it. So for some of you, this is going to be a review of what we did the other day. Try to pick two big numbers. I know these numbers aren't really that big, but and I'm probably going to hurt myself with, I like it when you guys give me numbers. If I tell you to pick a 3-digit number, then tell somebody else to pick a 4-digit one. See, I don't have you here to help me, so I'm useless. Not useless, but helpless. See if I have a calculator. Using this method, it helps to have a calculator. Hold on. Yep, I have a calculator. So some of you probably have calculators that actually you can just punch in two numbers and it tells you what the GCF is. So if I'm using a calculator, you're probably thinking, well, you're cheating, but I don't think my calculator can do that. I'm going to just show you, like, if you just have a regular $1, cheap calculator, how you can still do this. So what I'm going to use is what's called the Euclidean algorithm. Hopefully you can't hear my stomach growling. It's just like regular, normal class. my stomach would be making noises. So if you can hear it, then I guess it's normal. So how to find the GCF of two numbers using the Euclidean algorithm? You write the big number here, right there. It has to be right there. Equal sign. You write the small number here. Then I'm going to go like this for right now. You're going to ask yourself, what number, there's going to be a number in here. What number do I put here to multiply by this to get as close as possible to this without going over, like the Price is Right, sort of. And how you can figure that out, now you could just like say, well, I think 18 would work, but like if you didn't have a calculator, you could still do it. But with a calculator, you divide 2044 by 132. It says 15.48 repeating. Well, you get rid of that 0.48. Just write 15 in here. So I'm going to multiply 132 times 15, get 1980. You'd have to add 64 to 1980 to get 2044. Okay? So now what you're going to do is you're going to shift this number and this number over. So you're going to take 132, put 64 here, so you're going to shift it over. Then you're going to ask yourself, what do I have to multiply that by? So obviously, I don't need a calculator for this. I know 2 is going to give me 128, which is 4 away from this. So then you're going to shift this over. Just 16. 4 times 16 is exactly 64. So once you get to 0, which we just did, see, you have a 0 here. Once you get that, you're done. There's nothing else to do. The number above it is what the GCF is. So the GCF of 132 and 2044 is 4. Okay. Now see, that would have been hard to or harder to list out or do the prime factorization or find all the factors and list them out. So this method's really good. So now to find the LCM of these two numbers, I'm going to erase this. This is better, like usually when I'm given a class and I erase something, people complain because they haven't written it down yet. But this is a video, so you can go back and watch it anyway. I'm erasing this. We already found the GCF. So if I wanted to find the LCM of these two numbers, I could do what I did the other two ways. Do the prime factorization of these. Now, I don't want to do that. Those are kind of big numbers. It would actually probably be pretty easy though, since they're both even. Probably wouldn't take too long. I could just do what I did before and list out all the multiples. I think that's right. And keep going. Yeah, you know what? That would take way too long. So, what I'm going to do is I'm going to do it the way I just said. You can find the LCM of these two numbers. See, finding the GCF is easier than finding the LCM. So, a good way to find the LCM is to find the GCF and use the link between the two, where if you multiply the two numbers together and then divide by the GCF, I'll just write it out like that. I'll write the actual formula out. Probably should have timed this video. I want to know. Oh, it's on the screen. It's about to hit 20 minutes. So we have 132 times 2044. I don't know what that is right off the top of my head. But I do know the GCF is 4. So what I could do is just before you multiply these numbers together, you could divide by 4 first. Maybe I'll do that. This would be 511. Canceling out. I hope I did that right. I'm going to check anyway. Remember, that's what the calculator is for, right? Just checking. Oh, it is 511. Good. So what this amounts to is that the LCM of these two numbers is going to be 132 times 511. So you really didn't want to list all these out. 511 times 132. That can't be right. 511 times 132 is 67,452. So, see if you can still see it. LCM. So obviously this is my first video that I'm going to post. So if there's, I might not even post it if I don't like it, which I'm probably not going to, but so if there's something I'm doing that you don't like maybe I'm standing in front of the board too long or something, hopefully I'll get better. I'm not going to make a video for every topic. Like I might not make one for integers. I expect you to read the sections. I expect you to, if I post notes on Blackboard, to look at those. I expect you to visit my office hours, which I'm going to hold virtually, and I'll make an announcement on Blackboard about that. I think I already did actually. But some of the more difficult topics where you might need help, I'll try to do more of these videos. So like I said, LCM is important if you're trying to add fractions or subtract fractions. So I could either extend this video and start talking about that, or I could make another video at a later date where we actually use the fact that we can find the LCM or LCD of two numbers. That way we can add and subtract fractions. I think I'll just, this video is going kind of long, so I think I'll just stop and make another video where we use this fact, or use, you know, the fact that we know how to find LCM now to help us add and subtract fractions. So I hope everybody's doing all right, and if you have any questions, you can email me. Also, I'll make an announcement about this too, but my phone number on the syllabus is the phone number to my office, but I've had it forwarded to my cell phone, so you can call the number that's on the syllabus and I'll be able to answer. So thanks, and I hope this helps, and if you have any questions about it, don't be afraid to ask.